Good afternoon, everybody. My name is Clark Wenzel. I'm a senior PMT with AI Devices, and I'm here today to talk to you about AWS DeepRacer. Thanks for joining. So by the end of today's lab, what I really hope you leave with is having some understanding of what reinforcement learning is and how easy it is to get started with reinforcement learning in DeepRacer, starting your own model or training your own model, and then taking part in one of our warm-up races or going out and creating your own community race. So to get us going, let's see, how did we come about AWS DeepRacer? Developers told us in 2018 that they really enjoy deep lens and this hands-on way of interacting with machine learning. And so we thought, is there a way that we can make reinforcement learning equally interesting and hands-on? And so the idea of DeepRacer was born. It is an application of reinforcement learning to try and get a car to drive itself around a racetrack. And we've gamified it, obviously, as you can see with the 2019 AWS DeepRacer League. So what is DeepRacer? Well, we have a car, the physical car, and you can see next to me I have a DeepRacer Evo. We have a 3D racing simulator. And so you will train your models in the cloud, and there's also a fair amount of racing happening in the cloud. Then we have the league, and this is a way for you to go and showcase your skills and just, have fun and compete. And we also launched something at reInvent 2019 called Community Races. And this is basically where you can go into the console and you can create your own virtual races and enable your community to take part in these races, be that just friends or colleagues. And so let's go under the hood of the car. On the desk with me here, I have the AWS DeepRacer Evo. Let me just lift off the hood here. And you'll see that we use the same chassis, the 4x4 chassis that we used in AWS DeepRacer, the same Intel Atom compute. What we've done is we've extended it, showing you that it's possible to go and add additional sensors. So here we have stereo cameras, whereas DeepRacer, the original, only had one camera. And we've also added a bracket with a LiDAR on top. And so the whole point of Evo was to unlock additional learning. Like now you can learn how to add additional sensors into your network to make better observations on the state or the environment. And it also unlocks new kinds of racing. Like object avoidance and head-to-head racing, because our car is now able to discern whether there is an object in the road or not. Cool. And with that, let's move on and let's talk about the 2019 league and a recap of the league. So let's take a quick recap of the 2019 league. We had 21 races across 17 countries, and we had thousands of developers take part in our in-person races. The winner, or the fastest racer to that fact, was Solar in Tokyo in Japan with a record time of 7.44 seconds. And then we also had 6 virtual races, and we had 18 top point scorers join us from these virtual racers. And in the end, all of the winners and point scorers through our races joined us at reInvent 2019, where they took part in the Championship Cup finals. We had a elimination round followed by a double bracket elimination, and on screen you can see the results. Ultimately, again, Solar was the reigning champion in the final, beating out Fumiaki and Roger. And so this year, we're obviously rebooting the league again, and you will still have 2 ways to take part, the online and in-person racing. We're introducing 2 new race formats that I spoke about earlier, enabled through Evo. We have object avoidance and head-to-head racing in addition to time trial racing. And obviously we have prizes up for grabs. So if you win one of our races, you will get an entry into the Championship Cup final, or the Championship Cup. And you'll also win a trip to reInvent. And there's also other prizes like DeepRacer cars up for grabs. So on screen, I'm happy to share with you the list of summits that we'll be visiting this year. we've expanded, and now we're going to be visiting 37 summits. So there's a lot of opportunity in person to race, and you will be able to race in time trial format or in head-to-head racing. Time trial racing will take place using the traditional DeepRacer car single camera, and head-to-head racing is going to take place using EVOs. So when you train your models, make sure you train time trial models for single camera cars, and that you train head-to-head races on EVO cars with stereo cameras and or LiDAR. And in the virtual league, we'll be doing the same. We're expanding the number of race formats. We're doing time trial, object avoidance, and head-to-head racing. There'll be 8 months of virtual racing, so 24 chances to win. And we're already also adding a few additional enhancements to our virtual racing to make it more engaging and fun. Now, this year, Accenture is the main sponsor of the league, and we're very grateful for their participation in helping us bring the racing to all of you. Before we progress further with today's webinar, what I'd like to do is, on screen there's a link that takes you to the AWS DeepRacer page, where I'm going to ask you to create resources. And we're doing this now to save time later. So I'm going to jump to my screen to show you what this looks like. So this is the screen you'll see when you click on the Create Resources link. And this is where you need to create resources. If you haven't used AWS DeepRacer before, please click Create Resources now. What this is doing in the background is ensuring that your account has the correct IAM roles, and also the correct permissions to essentially go and call the AWS services that we use. And those are Amazon SageMaker, AWS RoboMaker, Kinesis Video Streams, S3, and a few others. And while this is happening in the background, what we're going to do is we're going to continue with our slideshow and talk through some of the requirements of, to get you up to speed on what reinforcement learning is. Okay, let's go. RL for the Sunday driver. The key takeaway that I really want you to take away from this is, reinforcement learning is used in everyday life by people, and the key concept that you need to take away from this is what a reward function is and how it's used in reinforcement learning, because this is also what you're going to use to train your first model later on. So artificial intelligence is really something that seeks to create machines that have human intelligence. And this is a very broad and general concept. And something that humans are particularly good at is making predictions about things. And so machine learning is one part of artificial intelligence that seems to replicate that human, or tries to replicate that human ability of making predictions. And it does this using statistics. So a lot of what you see in machine learning is essentially just statistical methods to try and build models that are good at predicting. And so there are a couple of different ways of building these models. And those are reinforcement learning, supervised learning, and unsupervised learning. And so supervised learning is typically something where it's example-driven training. You need a lot of data in order to train these models. Unsupervised learning, there is no labels for the training data, but it's trying to find categories or similarities in the data in order to try and predict based on what it's seen in the past, whether something is part of some category. And then reinforcement learning is something where the model actually learns by interacting with the environment, and that learning is fueled by what is the consequence of my action. And so we said reinforcement learning is used in the real world, and this is probably the easiest example. Think about training a dog for a dog agility course, or just in fact to sit. You'd go and reward positive behavior. You won't reward the negative behavior, and ultimately over time your dog will learn that there's a positive outcome if I hear the word sit, and I sit, and that's essentially you've now reinforced that pattern in the dog. So before we move on to talk about reinforcement learning in the computer sense, let's just clarify a few terms. So we're going to be talking about an agent, and an agent is simply our car or this model of ours that's driving around in the virtual world. And it's driving around in an environment. And in our case, we've created a 3D racetrack in our simulator. And at every point on this racetrack, our car is going to make an observation on what is the state, like where am I on my track, like what do things look like around me, what can I sense, and then based on that, it's going to say, I think I need to take a certain action. And it's going to take an action, and then there will be a reward. And if you think of this as one step, if you put a number of those, like look at the state, take an action, get a reward, if you put a number of those steps, together, you essentially get something we call an episode. And so just to get that out of the way before we progress, the reward that I spoke of there is something that is driven by the reward function. And if you think about the dog, we essentially had the reward function there. If I say sit and my dog sits and I reward him, then obviously for a behavior where he sits, if I say sits, he gets a positive reward. And so that is the function that really incentivizes the behavior in terms of like sitting down. And so that is the same thing we're doing in our own, or in DeepRacer. We essentially have this reward function that is incentivizing the driving behavior that we want the car to exhibit. So based on the outcome, we will reward the car. So let's maybe look at that a bit more practical. This is, the reward function applied in a grid race. This is a simplified racetrack. We have our car starting on the left, and we need to reach the goal. There are obviously many different ways that we can do that. And what we've done here is we said, well, we think that the optimal behavior is really driving in the center of the track because that's the shortest distance. So how can we go about incentivizing our car to drive on that yellow line? Well, a simple way of doing it would be to say in reinforcement learning, let's say that if my car drives on the center line, I will give it a higher reward than if it drives on the outer lines. And so the key thing to remember here is, just like our dog, initially the car doesn't really know where it's going to get the high reward or the low reward. It's basically going to try a bunch of things, and we'll get to that a bit later. And so over time, it's going to explore and figure out where these rewards essentially are, and that's going to reinforce the driving behavior. So here I have a small video to basically show what this looks like in practice. And you can see that initially the model starts off, or the agent, and it doesn't really know much about where to drive, only sort of when there's, the start and the end. And then over time, it's realizing that, I'm getting a lot of rewards if I stay on the center line. And so there's this thing that happens initially, which is called exploration. And the model iterates a lot. And then over time, we start seeing this convergence, which is basically the car is just staying on that straight line. Now, you want your car to explore the space initially, because if it doesn't explore enough, how will it ever know which path is the best? The trade-off there is if you explore too much, you essentially get into a space where it keeps on exploring, and it never really converges or selects like an optimal behavior. And that basically means that it's going to keep on training for a very long time, and it just won't, it's not going to settle down, because every single time that it explores, we're incentivizing it more to explore. And so here you'll see what that typically looks like when you start training your DeepRacer. You'll see that the car is first exploring, and you can see the car is going off track quite a bit. And then over time during training, you'll start noticing behavior which looks like this. My car has now learned to stay on the road, and it's exploiting what it has learned. So there's a lot less emphasis on exploration and more on exploitation. And in that case, you can also see that this model has converged because, our car is actually staying on track. So let's do a quick recap. It was a bit of a whirlwind tour, but we've spoken about reinforcement learning and it being a form of machine learning where we're interested in creating a model that, is interested in making autonomous decisions in some environment based on that feedback signal, the reward function. And so reinforcement learning in the real world is like training your dog to sit and giving it a reward. And so that behavior that we want to drive, we really need to capture that in our reward function. That's the star that you see on screen. And then just kind of a prompt is the practical application of a reward function is think back to the grid race. Like, what is the behavior that you want your car to show? What do you think is good driving behavior? It is that behavior that you really want to go and reward. And then the logic of reinforcement learning takes over. And through iteration and exploration, the model is learning where it can get those rewards. And then as it optimizes, it starts saying like, oh, okay, I need to now exploit what I've learned in order so I can maximize that reward. Now, we've spoken about this across the last few slides, but just from a learning is iterative point of view, think about it like this. We have our agent. It's making an observation on the environment. What is the state? And this happens about 15 times per second. It takes a picture of the track. It then sends that state into the model to try and get an action. And it then takes the action, observes its outcome. The reward function kicks in and says, hey, you were in this state, you took this action, and this was the outcome. And based on that, my reward is X. And it stores all of this in an array, and it basically repeats the process. And if it has enough data, which is something we'll get to a bit later, it starts training the model. Once the model is trained, that's not the final model. It then takes that model, it puts it back into the environment, and it restarts the process. And so it'll take the improved model, and it'll go a few episodes again to try and figure out, can I improve? And then it'll take the new data from the improved model, train again to get yet an even better model, and it'll take that model and restart the process to take more episodes. So we'll see this when we look at the console, when you look at the training graphs. And so just for those interested, what are we basically doing in the background? I've spoken about, the car is looking around and trying to observe what is going on in the state, then taking an action based on the output of some model. So in the background, this reinforcement learning that we're using is essentially training a neural network. And what you see on screen is the architecture. So the first component is we have something called a convolutional neural network. And the way that you can think about this is it is a form of extracting patterns from images. So if I feed a track into it, the CNN is going to try and hone in like, what are the interesting things on this track that helps me get to the action that will give me the best reward. Now, obviously, once we have those features, we still need to combine them all together in order to make an action. And this is sort of where the policy network comes in. It's basically saying, hey, crudely speaking, if you see two straight white lines on the side, that's probably a good indication that you should go forward. However, if you see them turn, that's probably a good indication that you should turn. Or not, rather, if you see them turn. If you see the lines do something like that, that means the action should be turning. And so typically what you want to do is ensure, a simple reward function is stay in the middle of the track. And we'll see that a bit later. So, again, a bit of a whirlwind tour through reinforcement learning. Let's now look at the virtual simulator to see what you will encounter later on in the hands-on lab. The key takeaways from this section will be to understand the environment in which the car will train and, sort of how you should think about crafting that reward function, like what is available to you. Second, I would say is, the actions that the car is taking, those are determined by you. And lastly, when you get started, there is a free tier to help you get started training your models. So what does a simulator architecture look like? Well, you can see we start off, you will interact with the console. It's going to make a call into Amazon SageMaker and AWS RoboMaker. And those two are essentially, SageMaker is doing the training and RoboMaker is doing the simulation for us, the 3D simulator. There's some data exchange between them, obviously, as we start collecting episodes and, state action rewards. We store them in S3, SageMaker picks them up, does training, sends the model back through S3 to RoboMaker, and so this iterative process continues. And then finally, we store logs and things like that in Amazon CloudWatch, and you can also see the video in Amazon Kinesis video streams. Now, if you have a car available, you can download the model and race the physical car, but you don't actually need the car in order to use the service. You can train models, you can race virtually without a car, and you can also go and race at our in-person competitions, and we'll be providing cars at those competitions. So this is what you'll encounter when you program a reward function, and we're not going to speak about it too much now because we'll actually look at it in person. But I guess the big call out here is it uses simple Python syntax, and we have a couple of example reward functions to get you started with your time trial model. Importantly here is we spoke about how do I know where my car is so I can reward the outcome of an action. And we have a few things on the track. We have a wall around the track. We have a field, which is considered off track. We have the track surface and the boundaries, both which are considered on track. And we also have the center of the track. And so these are all things that can be used to, determine sort of where the car is on the track. And so we provide things such as waypoints and track width and heading, which we'll talk about later, that you can all use to influence your reward function. For example, you can say, if my car is further away than, let's say, X from the center line, I want to make the reward smaller. However, if it is on the center line, I want to give the biggest reward. Now, if it's off track, I don't want to reward it. And in fact, what we do during training is we actually reset the car, and your car is not going to explore off track to try and figure out how to get back on track. So we kind of reduce the amount of training because that would take a very long time to train. And so what does heading really mean? This is just, it describes the orientation of the vehicle in degrees, and it's measured counterclockwise from the x-axis, of the coordinate system. And so you'll see that, at every single point in time, when this reward function is being called to reward the outcome of an action, it's going to basically say, this is your new heading, and this is your new XY location, etc. So what we'll do now is we're going to dive into the hands-on lab. And so before we get there, I just quickly want to show you on screen a couple of the links. You can find the lab content at bit.ly/DeepRacer 2020 lab. The goal here really is we want you to build a time trial model, and we've created a warm-up race just for the webinar. So the link is also there at step number 3, where you can see bit.ly/techtalkfeb20. If you click on that link, you will basically be taken to a community race that we've created, and we will, the top 10 racers in that race, when the race closes, will each win $200 of AWS credits. Now, if you feel that's not a big enough challenge for you, there's also the AWS Innovate ML conference race that's going on at the moment, and the link is on screen. And all of this is basically done so you can start training your models in preparation for the 2020 League, which is going to launch in March. So what you'll see here is the AWS DeepRacer models page. Let me just quickly show you how to get there. If you navigate to DeepRacer, you may see this screen, the landing page. You go to get started. You'll see that earlier on, this is where we went and we created our account resources. So we did that because you need account resources before you can train models or race in the league. And so if you go from that to models, you will see 3 example models. A sample, prevent zigzags, stay on track, and follow center line. I went ahead and I trained 2 additional models that I'll show you now. And so let me show you how to create your own model. I think the first thing is when you go and create a model, you need to think about a couple of components. I have this agent that is going to race around the track. So let's go to Garage and just see what agents do I have at the moment. Well, you'll start off and you'll see the original DeepRacer. This is a car where it has a single camera, a 3-layer CNN, action space of 1 meter a second, and steering angle of 30. It's possible in here to create your own vehicle. And I basically did the exact same thing. I went and I created a single camera car, a 3-layer CNN, a speed of 1 meter per second. Let's maybe just quickly have a look and see what that looks like. Rather, I want to go and build new vehicle. So we can select camera. So for time trial races, highly recommend single camera. That's what's going to be used at the summits. At summits, something like stereo camera, LiDAR is typically what we'll be using for our head-to-head races. And so we're going to stick to the single camera because we just want to build a time trial model, and training a single camera model or single camera model for time trial is a lot faster than training a stereo camera with LiDAR. And I'm also going to use a 3-layer CNN because that's sufficient for our use case here. Next, we'll see the action space. The action space is the list of actions, and you can see them at the bottom, that your car can choose from. So you can see the car can choose to go 30 degrees negative, which is typically left, and you can see here on screen what that looks like, and a speed of 0.5 meters per second. The second action is 30 degrees, 1 meter a second. And so we can quickly change this here. We will basically just say, I want the maximum speed to be 1, and I only want to have 1 speed. Like, you just go 1 meter a second, and that's it. Now, when you train and iterate models, you may want to play around with the speed. But the one thing I'd like to call out is, just because you see a number that says 4 meters a second, know that those models typically take a lot longer to train. And when they start training, because the car is traveling at that speed, you will often see your car spin off track. And so you may find that training a model at 4 meters a second really doesn't converge at all because the car is not capable of staying on track. And so this is one of the things you need to consider. What is the optimum speed to choose in order to build a model that is fast but still capable of finishing the race? So I'm going to stick to 1 meter a second. And I'm just going to give my car a name, any racer, and leave it as black. Done. So the next thing is, now that I have a car, I want to go into models. And as you can see, I have a list of the models. I'm going to show you how I created this basic 2-hour larger model. In the create model screen, you'll see you've already created account resources. Next, we'll go and provide a model. Let's just call this webinar racer 1. And you can provide a training job description. This becomes useful later on when you want to go and filter through your models to say, like, what exactly, just a quick view, how did I train or set up this model? So you may want to say, this is, a 1 meter per second model, 1 action, or 1 speed rather, 5 steering actions, 30 degrees, something like that. And later on, when you get fancy, you can also use things like hyperparameters. Now, I'm going to select my environment. This is the track that you're training on. And so what you'll notice during the summit races is all the summit races will take place on the 2019 DeepRacer Championship Cup track. So the track that was at reInvent is going to be the same track that will roll out on all summits, and both time trial and head-to-head racing will take part on that track, will take place on that track. And so by building this model, you can take your model and go and race at the summits. And also this race that I spoke about earlier, the Tech Talk race, I created using this specific track. So always think about where am I going to race, because I want to increase my chances of success. So I want to train on a track that I'm going to race on. And we're going to go next. And here we can see what is the race type. I spoke about those race types: time trial, object avoidance, head-to-head. We're going to train a time trial model. The agent, here you will see the original, any racer. I guess the big call out here is that even if you select, well, you can't edit the original, but if you select one of the ones you created, you can still go in and make changes to your car. And that's going to basically feed back into your training. And so you can edit it on the fly here. And so we'll just select the car that we created, or the original is good enough as well. Go next. And here's the very important piece for today, the takeaway, the reward function. So we have a couple of reward function examples. We have the time trial, follow the center line. We have stay inside the two borders. We have a zigzag, and we have an object avoidance and head-to-head example. I'm going to stick to follow the center line example. And what you can do is once you've selected it, you can say use code, and that's going to populate this. And so we have a number of parameters in here that we're using to determine how do we reward our car. And so what you can do is, if you are working through the workshop lab, the hands-on lab in your own time, you will see there's a big description or a table showing the description of all the different parameters you can use. And you can also see there's some additional info on input parameters on the side. And if you click learn more, you will go to the documentation where we've detailed all of them. Or if you know Python well, you can actually put print statements inside this reward function, and it will print out the different parameters to your logs. And so what we're doing here is we're basically trying to reward the agent for staying on the center line. And so we can see we have something called track width, which basically describes how wide is our track. And we have something called distance from center, which essentially is just that. If you take the track width, which for the reInvent track is around 42 inches, we can basically go and say that, hey, the center of the track is sitting at 21 inches away from either side. And so the measurement is typically going to be, and all of this will typically, I think, be done in centimeters or meters, but you get the picture. It's just a certain number of inches. And so what we've done is we basically took that track width and we carved it up into 3 different lanes, if you want, or rather a couple of different bands on either side, where we say, if you stay, the one is 10% of the track width. The second one is 25%, and the third one is 50%. And so we're saying, if your distance from center is less than marker 1, meaning you are closer to the track than 10% of the track width, we'll give you a reward of 1. The further away from the center of the track you go, the lower your reward. So if you think back to our grid race, what we're doing here is exactly that. We're saying if you stay on the center line, we'll give you a big reward. And as you move further out, we'll decrease the reward. Now, this is a very simplistic reward function. I have a link that I'll share later on, but we have a number of our community experts that held something called the Expert Bootcamp at reInvent 2019, and we've recorded all those videos. They're available on YouTube for you to watch, which will go over how to really build an expert reward function. And so if you feel like giving it a shot and winning a trip to reInvent, I would highly advise that you go and watch some of those videos because they do share a lot of wonderful tips. Now, the next thing we're seeing here is training algorithm and hyperparameters. And so we're not going to dive into much of what PPO stands for, but we are going to talk quickly about hyperparameters. The big thing to call out in hyperparameters is that they affect your training quite a bit. The hyperparameters that you see on screen will work quite well for the base reward functions or the example reward functions that we provided. However, you can go and play around with them. Again, there's a useful info button if you want to read more about these hyperparameters, and they're also detailed in the lab. But I think a few quick callouts here would be, let's start off looking at the learning rate. If you think about a learning rate, so what is that? We've spoken about the model being trained and then, more data being collected and the model being trained again. The learning rate typically impacts how much we update our network every time that we train our network. And so if you have a very large learning rate, it typically means that your model will learn faster. But because we're working in an interesting space where there's some optimization that's happening, the amount that you learn by, if it is too large, it also means that you will never really, you could actually miss the optimal point. And so the trade-off here is if you have a learning rate that's too large, you may also find that your model is struggling to converge. I think number of epochs, this is an interesting one. It basically just says that, when it's at 10, it basically says that every time that SageMaker takes over and trains the model, it's going to go through the data collected at that point in time 10 times. And so if we make it 5, it basically means it's going to update my model or train my model 5 times before it goes out and collects additional information or additional data. And what we have here is batch size. This is just saying, take the training data that I just collected and cut it up into batches of size 32. 32, let's call it steps. And so the model that I trained earlier, that I'll show you, I basically used a learning rate of 0.0005. I reduced the number of epochs to 5, and I decreased my gradient descent batch size. So the logic behind that was I'm using a slightly larger learning rate, so my model will train faster. I'm decreasing the batch size, so my data is cut up into smaller bits that I'm essentially going through 5 times in order to build a better model. And I think there's a lot of tweaking and playing around with these things, but I use these and they worked well. We have things like discount factor, then loss type, which I wouldn't change, and number of experience episodes between each policy updating iteration. This basically just says if your car goes out and it has collects 20 episodes, it's going to kick off a training job in SageMaker. Once that is done, the number of epochs, it's going to go out and try and collect the next 20. And then we have something here called stop conditions. So I trained my model for 120 minutes, and this is within the free tier if you haven't used DeepRacer before. Obviously, you're more than welcome to make this something like, let's say 10 minutes and just see what the output looks like before you go back and increase it. And then I'm going to hit, create model. And what this is going to do is it is now orchestrating everything in the back end, spinning up SageMaker and RoboMaker and starting the training. And what you'll see happen is, I'll show you what it looks like. Basically, over time, you will see a chart that looks like this. Let me zoom out a bit. And this is an important chart. It's basically our reward graph. And it shows you a few things. It shows you what is my average reward that I've received in this training iteration. And so you can see obviously a reward going up and to the right is kind of a good thing. Over time, if you train your model long enough, you will see this flatten out. And this typically means that your model is not really learning anything new. It's essentially now started to converge. It may not be the best model yet, but how would you know? So what we're also showing is we're showing the progress. And this is important to see because it is entirely possible to build a model where the reward flatlines and your progress stays below 25%. I've built quite a few models like this. And those models typically don't work well. And so what I would do then is it either means your reward function is not providing the right signal for the model to train on, or your hyperparameters were chosen incorrectly. And so this can happen if your reward function is really large. We also have the specific progress per episode. So I'm just going to switch off reward. And so what you can see here is I actually have a number of laps during training where my car was able to complete the track 100%. But on average, in that specific, in that 20 episodes of training, it managed to complete 73 or 63% of the lap. And so what you'll also see during training, once it starts spinning up, is you will see a video showing you what the training looks like, and you can watch that. Now, once this is done, what you can do further is you can go and evaluate your model. And you can do that simply by clicking Start New Evaluation. And what an evaluation does is it'll basically go and take your model, you will select a track. You can select your track that you want to evaluate on. You can select the number of trials. This basically just means 5 laps, 3 laps, 4 laps. And we train the time trial model, and you can click Start Evaluation. And what this is going to do is essentially go and see how well your car is performing in a time trial race on that specific track. So let's see what the progress is on our other model, if we can see the video. This typically takes some time to start, and you can see there it says initializing, and the reason for that is we're basically starting up RoboMaker simulation as well as spinning up SageMaker, and the orchestration takes about 5 minutes. And so when it's ready, you'll start seeing your model moving around the track, and you'll start seeing data being populated here. Obviously, you may see some interesting artifacts, such as when the car stops moving on the track, it could imply that like here it's still initializing, or SageMaker is busy training, and so it doesn't need to move the car. And then when RoboMaker takes over in the simulation, it basically says, okay, let's start moving. Cool. So I don't want to delay us a lot here. What we can do is, let's see how we can take your model when it's done training and go and race in this competition that I spoke about earlier. So I know we went a bit quick today, but all the steps that I described to you now, you will find in this in the lab on GitHub that I shared with you. And you can follow them in closer details in that specific lab. And then I also posted a couple of links in there specifically to the expert bootcamp that I spoke about. And so what you can see actually here on screen is this is the evaluation that I launched a bit earlier. And you can see that my car is not, it's not driving superbly. It's staying on the track, but it can definitely improve. And you can see that, by following the center line, perhaps that's not the best racing line around this track, which is something that I think some of our expert racers have uncovered how to do. Now that your model is training, let's maybe see how you can host your own race. So, you can really unlock the potential of machine learning with your own DeepRacer race. We saw triple-digit races happening outside of the 2019 league, and here's some of the key reasons why they happen. So customers found that, using DeepRacer, they can learn about machine learning in a fun and engaging way. And so you can upskill your community, your employees, and it's also a way to promote innovation and that ML thought leadership. And so what that means is essentially helps people to think about problems in a machine learning way. Like, I have an environment and I need to build some model that can make autonomous decisions in that environment. DeepRacer is a way to make that tangible and practical. And then I guess the leap there is, how do you take this concept and see in your own organization where there are opportunities for you to apply similar technologies? And so again, DeepRacer is just an application of reinforcement learning. But once you dive into it, you can also play with supervised learning and unsupervised. And we have a few companies, Accenture, Morningstar, and Liberty Mutual, that had their own races last year, global races, which were a lot of fun. And so what we can do now is you can launch your own virtual race in the AWS console. I'm not going to go through I'm not going to show it on screen, but here are the required steps in order to do that. This is how I created the Tech Talk race. So what you can do is you can go to the AWS console following that create virtual race link. Then you can create your race and populate the details. And these are just, what is the start date, the end date, what is the track, how many times do you want to evaluate a model each time that it's being submitted. And once you're done, you can confirm the race, and then it creates a link for you. Now, this link is the access to your race. Once you've shared it with somebody, they can access your race. As the administrator, you can obviously remove people from your race. You can deactivate the link. And so what you'll see there in step 5 is start racing. And if you want to click on that link or just type it into your browser, bit.ly/techtalkfeb20, that is the specific webinar race that I've created for this webinar. So let's go there now. Okay, so if you've never raced before, what you'll see when you click on the link is, provide a race name. So webinar racer is my name. And now I've set my alias, and you can see this race should be open by the time that you see this webinar. And when the race is open, you will have the ability to submit your model into the race. And what you can also do is you can go to community races. You can see which races you've subscribed to. And you can also create race and manage the races that you've made. So let's go back and close out with some additional resources and see how you can warm up properly for the 2020 league. Okay, so on screen what you'll see is a couple of really good links that I advise you to go and look at. So for details on the 2020 league, you can go to www.deepracerleague.com. It'll show you which summits we'll be visiting. It'll show you details of the virtual racing. Then we also have the expert bootcamp videos. For anybody interested in building good models, I would highly advise that you go and watch those videos. They shared a lot of useful tips on, how to create a reward function, how to select good hyperparameters, action spaces, etc. We also have the DeepRacer Slack community. This is a, organic community that started out of London, and they basically discuss anything from real world racing to virtual racing. They also have some of their own races. We also have a blog that they started. If you want to learn a bit more, we have a AWS training and certification video course. That's the DeepRacer course on screen. If you have a DeepRacer, or if you want one, you can buy one off of Amazon.com, and then building a real world track, we also provide documentation on how to do that. And so with that, what I would like to say is thank you very much for joining me today. Be sure to train your models and get ready for the 2020 League, and then go and take part in this webinar race. As I mentioned, the top 10 people will each win $200 of AWS credits. And there's also another race going on, and that is the AWS Innovate Race. So it's a machine learning conference that will be online, run by AWS, and they've created their own DeepRacer race for you to take part in with its own prizes. With that, I'm Clark Wenzel. Looking forward to seeing you at the races in 2020. Thank you.